All right, let's finish out the notes from today. I want to go back and look at a few of the examples that we skipped because I feel like we kind of rushed through some stuff. So if we go back to example 1C, we want to write the explicit and the recursive formulas for this sequence. Now remember, our explicit formula is a sub n equals d times n minus 1 plus a sub 1, where d is the common difference and a sub 1 is the first term. So to get the common difference, we just want to look at the number that we're adding every time. So here, I'm actually going down by 1/4 every time. So my common difference is going to be negative 1/4. Now, if you can't see that right off the bat, the easiest way to just calculate it is take a term and then subtract by the term before it. So if I do 3/4 plus 3/4 minus 1, I get negative 1/4. If I do 1/2 minus 3/4, I get negative 1/4. If I do 1/4 minus 1/2, I get negative 1/4. Okay, so that tells me the number that I'm adding every time by going backwards. Right, I'm taking a term and subtracting by the one before it to figure out what I should add to this term to get this term. So to write my explicit formula here, that's going to be a sub n equals my common difference times n minus 1 plus my first term, which is 1. Then the recursive formula we said was just a sub n plus 1 equals a sub n, and then plus the common difference. So in this case, that would be plus negative 1/4 or just minus 1/4. And what this means is to get the next term, take the previous term and subtract 1/4. Okay. Then d here, again, I need my common difference. So again, we can probably see that we're adding 1.5 every time, but if you can't see that right off the bat, to calculate that, take any term and subtract the term before it. So I would end up with d is equal to 1.5. So my formula, a sub n equals the common difference times n minus 1 plus my first term. Then the recursive formula, we can write it as a sub n plus 1 equals a sub n plus the common difference. So in that case, or in this case, 1.5. All right. So we also skipped example 2b. Okay, I think these ones are the ones that take the longest. So I want to go through another one of these because they can be a little bit tricky at first. So we want to set up a system of equations to solve here using our a sub n equals d times n minus 1 plus a sub 1. So here, the third term is 7, means that a sub 3 is equal to 7. So if I'm thinking about this, right, my n value is 3, so I'm plugging 3 in for n, and then my a sub 3 is 7. So I can write this as 7 equals d times 3 minus 1 plus a sub 1, and I can change that to 7 equals 3 minus 1 is just 2, so 2 times d plus a sub 1. And then this other piece tells me that my 23rd term is 17. So again, n would be 23. I could write this as 17 equals d times 23 minus 1 plus a sub 1. And we can simplify that to just be 17 equals 22d plus a sub 1. So remember, we talked about two different ways that we could solve this. In the example in class, we solved both of these for a sub 1. Right, so subtract 2d over, subtract 22d over, and then once they're both equal to a sub 1, then we can set those equal to each other. I'm going to do this a different way, just so we have two examples of how we can do a problem like this. So I'm going to just rewrite this one underneath over here. So now I have a system of equations, and I can use elimination. So the easiest way to do that is going to be to get the a sub 1's to cancel out. Well, if I just multiply one of these equations by -1, which will end up just changing the signs on everything. Okay, so if I multiply this whole top equation by -1, and then I can add straight down. They're already lined up to add, so -7 and 17 would be 10. -2d plus 22d would be 20d, and then the a sub 1's cancel out, right? Negative a sub 1 and positive a sub 1. So now, to solve for d, I just need to divide both sides by 20. And 10 over 20 is just 1/2. So then, I still need to find a sub 1. So to do that, I will take 1/2 and plug it back into either of these equations. I'll do it into the first one. So 7 equals 2 times 1/2 plus a sub 1. 2 times 1/2 is just 1. Subtract that. Oops. That should be plus a sub 1. Subtract the 1 over, and we get that 6 is equal to a sub 1. So now, putting all of that together into this formula, we now have our common difference. We now have our first term. My nth term is going to be a sub n equals 1/2 times n minus 1 plus 6. Okay, and we could double check this to make sure it works. We could plug 3 in. So if I plug 3 in, my third term, 3 minus 1 is 2, 2 times 1/2 is 1, 1 plus 6 is 7, checks out. If I plug in 23, 23 minus 1 is 22, times 1/2 is 11, 11 plus 6 is 17, checks out. Okay, so this would be my final answer, my nth term formula. Okay, so now we kind of rushed through some examples on the back of finding a sum. So remember, our formula to find the sum of the first n terms of an arithmetic sequence is n over 2 times a sub 1 plus a sub n. So we need the number of terms, the first term, and the last term. Well, I can see the first term and the last term, but I don't know the number of terms. So I need to set up my formula. I need to do a sub n equals d times n minus 1 plus a sub 1. So from this, I can see that my common difference is going to be -5. Right? I'm subtracting 5 every time. So I can write my rule as a sub n equals -5 times n minus 1, then plus a sub 1, which would just be -3. So now what I want to do is figure out, well, what term is -48? So to do that, I'm going to plug -48 in for a sub n, and then solve for n. So I'll add 3 over. So I'll be at -45 equals -5 times n minus 1. Divide both sides by -5, and that will get me +9 equals n minus 1. Add that 1 over, and I get that n is 10. So what that tells me is that -48 is the 10th term in this sequence. So to get the sum of those 10 numbers, I'm going to say s sub 10 equals 10 over 2 times the first term plus the 10th term. All right, so this ends up just being 5 times -51, which would end up being -255. Okay, so we need the number of terms, first term and the last term. And usually to find the number of terms, if we're just given a list like this, we need to set up an equation and solve for the n, right? So on this next example, though, we are given the number of terms in the first term, but we don't know the last term. So again, if we want to use this formula, S sub n equals n over 2 times a sub 1 plus a sub n, I'm missing a sub n this time. I'm missing the 40th term, and I know it should be the 40th term. So we're setting this up as S sub 40 equals 40 over 2 times the first term, which we can see is 8, plus, but we got to figure out what the last term is. Well, again, to do that, we're going to need to set up our formula. So a sub n equals d times n minus 1 plus a sub 1. So I know that I can see my common difference is I'm adding 2 every time. So a sub n equals 2 times n minus 1. And my first term, I can see, is 8. So now, I want to just plug in 40 for n. I want to figure out what the 40th term is. So a sub 40 is going to be 2 times 40 minus 1 plus 8. Okay, notice this is different than the last one because I'm plugging 40 in for n. I'm not replacing this with what I know the last term to be. So a sub 40 is going to be 2 times 39 would be 78 plus 8 is going to be 86. So that's the value that's going to go here. Okay, so this will end up being 20 times 94, and 20 times 94 is 1,880. So if I were to add the numbers from 8, again going by 2, 8, 10, 12, all the way up to 86, if I were to add all those together, I would get 1,880. Right? So the last, oh no, we get 2 more examples. For example 5, we want to find n if we know that a sub n equals 120, and we're going 2, 4, 6. So again, we need to use this formula. A sub n equals d times n minus 1 plus a sub 1. So I can see my common difference is 2. So 2 times n minus 1 plus a sub 1, which is also 2. So now I want to say that my a sub n is 120. So this is just like the first part of the example that we did a little bit ago. Okay, so I want to solve for n, right? It says find n. So if I subtract 2 over, I have 118 equals 2 times n minus 1. Divide by 2, and that'll get me 59 equals n minus 1. Add the 1 over, and we get that n would be 60. Okay, so 120 is the 60th term in this arithmetic sequence. All right. Now the last example is a little story problem. Okay, so it says walking up a steep hill, Jan walks 60 feet in the first minute, 57 in the second minute, 54 in the third, and so on. How far will Jan walk in the nth minute, and how far will Jan walk total in the first 15 minutes? So what we're looking at is a sequence that goes 60, 57, 54, and then continues on that pattern. So first, we want to think about writing an explicit formula. A sub n equals d times n minus 1 plus a sub 1. So I can see that my common difference is negative 3. And I'm going down by 3 every time. So a sub n is going to be negative 3 times n minus 1. And my first term is 60. Okay, so this would be my nth term. This answers the first part of the question. How far will Jan walk in the nth minute? Now to figure out how far Jan walks total in the first 15 minutes, we need to think about finding a sum. So we need to use our S sub n equals n over 2 times a sub 1 plus a sub n. So I need a couple pieces of information. I need n first term and the last term. Well, n is going to be 15 in this case. We want the total for the first 15 minutes. So S sub 15 is going to be 15 over 2 times the first term, which we know is 60, plus the 15th term, which I don't know. But we have our nice formula over here that we can calculate that. So a sub 15 is going to be negative 3 times 15 minus 1 plus 60. So negative 3 times 14 gets me negative 42. Negative 42 plus 60 gets me 18. So that's the value that's going to go right here. 18 is my final term. So now we can calculate this. Let's see. So that ends up being 585 if we plug that in the calculator. And this is a story problem, so we do need to label it. We're talking about feet. So in the first 15 minutes, Jan walks 585 feet. All right. I do want you to try the homework that's on the bottom of your paper. And we will do geometric sequences and series tomorrow.